Good afternoon, everyone. Our final panel on the center stage brings together leading AI experts for a discussion of key technical trends that will shape AI innovation in the years ahead. Please join me in welcoming Anima Anandkumar, Bren Professor at Caltech, Ramayya Krishnan, Dean of Heinz College at Carnegie Mellon University, Tom Mitchell, Founders University Professor at Carnegie Mellon University, and Daniela Rus, Director of the Computer Science and Artificial Intelligence Laboratory at the Massachusetts Institute of Technology. Jack Detsch from Foreign Policy Magazine will moderate the discussion. Please give it up for our panelists.
Well, good afternoon, everyone, and thank you for being here for the last session of the day. This should be a good one because we've spent a lot of time at the conference talking about the current applications of AI, chatbots, data culling, you name it. Now we're going to look a little bit into the future of what's to come with AI with this panel of experts. So Dr. Anandkumar, I wanted to start with you and talk about and kind of go down the line, looking at what you think some of the most exciting applications of AI are upcoming in the next 5, 10, 15 years. I know you've been steeped in the open source stuff that we were talking about backstage, but would love to hear your thoughts.
Yeah. Thank you for having me. And it's an exciting time for AI as somebody who's been working in the field for almost 2 decades, counting grad school. So it's great to see how much progress we've made. And there's a lot of attention on language models and multimodal models, which have language and vision and video. But I think the next step is going even beyond these modalities to understand all of science, engineering, and other kinds of data and processes that drive the world, right? So how do we get to that physical understanding? And not only the physical understanding of the world we observe, but also the world that is hidden from us, like looking at understanding molecules and proteins and those interactions all the way from quantum level to processes that happen at planetary scale, such as weather, and from weather, how do we think about climate and climate change? So all of these physical processes seem quite different, right? There is a lot of different verticals or domains you can think of where we have to model, simulate, design. But I see a world where we can have a universal model that is able to understand and simulate these processes and do it much faster than what we are able to do with traditional simulations, and also be able to directly generate optimized designs for lots of use cases. You can think of more efficient aircraft, drones that fly under turbulence, better rocket propulsion. So all these hard engineering tasks, what's considered as deep tech and what is considered as quite separate from AI today will be all fully integrated into systems where we can design with physical validity, where we can simulate different scenarios that's hard to create in the real world and reason about them and come up with better inventions and discovery.
It's a very optimistic take, Dr. Krishnan. Do you have as optimistic of a take? I know there was some optimism backstage from you and your colleague, Dr. Mitchell.
Absolutely, and Anima covered a lot of ground there. I'd like to offer some practical metaphors, I guess, in terms of how AI might be integrated into the work that we do daily, as well as the lives that we lead. So I want to, if folks can think back to before we had mobile phones, before we had Excel, before we had Google Maps, how did we, I don't know how many of the folks remember going to the AAA office and looking for a triptych to go from one place to another. We don't do that anymore. Google Maps has made that totally not necessary. The same with before Excel, we used to sort of do some things very, very differently. I really think AI is going to be ubiquitous in what it is we do and in everything that we do, be it workbenches for doing science or doing business decision-making or societal decision-making, or the kinds of things that become part and parcel of our lives. So rather than point to any particular technology advancement that might happen, I'd like to think about what outcomes might come about. And I think the kind of outcome I expect, it'll become so part and parcel of our lives that we won't be thinking of that is an AI and this is not an AI. It'll just be so much integrated into what it is what we do.
So I just want to jump in and quote Mark Weiser, who said, "The most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they become indistinguishable from it." So Mark said this about pervasive sensing. And it's really so exciting that we have evolved our technology or understanding that we can begin to dream about this idea for AI. I like that very much.
Well, don't need any prompting this panel. Not like LLMs, although we'll talk about that later. Dr. Mitchell, curious too how you sort of see things shaping up. It seemed like you were very optimistic about the state of play of regulation, of how lawmakers are seeing this.
I am optimistic, and I agree with these comments. One thing I would add to that, though, is when I think about AI applications, I think there's a big dividing line between what we'll call knowledge work applications and physical work applications, robotics. And what we're seeing, if you really look at where the advances have come from in the past couple of years since the advent of ChatGPT, it's really in the knowledge work area. They help us by digesting big documents and summarizing them, or digesting meetings that we have and summarizing those and the action items. In a way, the metaphor I like is they turn each of us into a CEO. CEOs are people who have a lot of resources behind them. When they have to make an important decision, they can afford to have a collection of advisors who are specialists in different areas and provide them the information they need to make those decisions. AI is already beginning, we're not there yet, to effectively make each of us a CEO in that same sense. But that's a knowledge work thing, not a physical work thing. And my friend Daniela works a lot in robotics, but I have to say that I'm less optimistic about the rate of advance in robotics, simply because if you want to build an android that has this many fingers and joints, you have not only the software problem, you have the mechanical design problem, and more importantly, the mechanical maintenance and failure problem that we never have when we're dealing with software only. You also have the problem that you have to actually build and ship around the world these machines, whereas, as we saw in the case of ChatGPT, in a couple of months, 100 million people already had a copy. So I think it's important in thinking about the future to distinguish these software-only knowledge work applications from physical embodiments, robotics applications.
Doctor, you've been steeped in the robotics angle, and of course, Tom just prompted you there. Where do you see the intersection and also the potential limitations? I know we were talking about that as you came to stage.
Well, so let me start because you asked about what you see about the future. So let me say something about that. If we look at the distant enough future, I really imagine a world where with AI, we can solve all of our grand challenges. We can solve the economy. We can solve governing. We can solve climate. And these are really big aspirations. We're not quite there yet, but when people talk about AGI, if you think about it, that's the kind of thing that AI could truly enable. On my side, I'm very excited about using AI to understand intelligence and to shed light into life, into human life or into the lives of our neighbors on this planet, whether they're the whales or the lions or the elephants. We share this beautiful planet with so many other species that we don't know much about. With AI, we can actually uncover some of those mysteries. Now, of course, Tom talked about AI for the physical work. I'm very excited about AI for physical work and also for cognitive work. And with cognitive work, I think that AI is giving us all superpowers, and I kind of see sort of an ever-expanding ring
that grows the capabilities. So we get support with speed, with knowledge, with insight, with creativity, with foresight, with mastery, with empathy. Today we have certain levels. Tomorrow we're going to have bigger levels, and so forth. And that's super exciting. With physical work, we also get physical empowerment. We get empowered by reach. So with physical tools, we can go beyond where our body can on its own. So we get reach, we get strength, we get precision, we get vision, we get the ability to see the unseen. We get lift, we can overcome gravity, we get time back. We even get magic, right? So a lot of the things we read about in Harry Potter, those are capabilities we can bring to bear with hardware, robotics, and computation in general. So we have a lot of great places to go to. But I do want to say we've all been so optimistic. There are still technological challenges, and we're not quite ready to deliver on all of these ideas. There are technological challenges, but also we have societal and economic challenges that we have to be faced with. And like, here's an obvious one. All these techniques that empower the good people to do great things, they also empower the supervillains to do bad things. So how do we stop that, for example?
Yeah, I want to get to that in a second, but just to recap where we were across the panelists, some words that came up: the ever-expanding ring of AI, ubiquitous, invisible. As we look towards this future world where AI is enabling almost everything, I'm curious about some of these ubiquitous uses and at how it will resemble today's world versus the expansion. I know, Daniela, you just touched on some of them, but Dr. Anandkumar would love to hear your thoughts and come down the line.
Yeah, so I want to go back to focusing on how we can change the way science and engineering is done today with the use of AI, right? So if you think of the scientific method that started with like around the time of Newton, the basic philosophy hasn't changed much. The idea is you come up with certain hypotheses and then you go test it out in the lab, get feedback, and then repeat this process again and again. And that's what makes it slow, right? I mean, if you have an idea of a design for a better aircraft wing, you have to first go, put this into CAD design, then simulate it, then take it to wind tunnel. And then if that's not so good, you don't even know how to change it. You have to use the human intuition today of somebody who's had decades of expertise to go and make those design changes. And to me, AI can make an impact on all of these aspects. You can think of now AI coming up with good designs or good ideas. We already have ChatGPT giving you designs of like better shapes or even better molecules. But then the hard part is not just coming up with ideas, but also to go test it out in the lab. And then the question is, can we build with AI digital twins that accurately mimic what those experiments would do? And then because it's AI system, you can directly optimize within that system and look what is the best design or the best idea. To give you an example, over the last year at Caltech, we invented a better medical catheter. So medical catheter is a tube that you use to draw fluids out of the human body, used in hospitals. The leading source of healthcare-related infection today, more than 500,000 cases annually. And it's a known fact that if you spend long enough in a hospital, you are getting this infection. And it actually goes back to fluid dynamics, how this happens. The bacteria tend to swim upstream along the wall of the tube where there is less friction. And so using these principles of physics, we used AI that could understand how the fluid flows and then come up with the design of ridges. What is the best position and shape of the ridges so that it can create vortices and the bacteria get thwarted and cannot swim upstream, right? So there is the idea of like, you need this to prevent bacteria coming upstream. But now AI can understand fluid flow and directly come up with an optimized design, which humans aren't very good at understanding fluid flow to begin with. So this is where AI proposing a design, and then we only had to 3D print it once in the lab to test, and it showed a 100-fold reduction in bacterial contamination. So instead of this traditional process of repeated trial and error and come up with ideas, go test in the lab, keep repeating that, what if now we had AI that can intuit and come up with physically valid designs? And you still need some testing in many cases, but even if the AI model is wrong to begin with, you can use the data from those physical experiments to further adapt and fine-tune the model to get better in looking at how the physical world is and accurately build those digital twins. And so you can now think of much more bigger systems and complex systems that otherwise we would have no idea, to be able to simulate. So one of the exciting examples we are working on is nuclear fusion, and the ability to understand how the plasma behaves, which is highly nonlinear and unstable, and do this about 1 million times faster than what we could do with traditional simulation. And now we are taking it a step forward with our collaborators at the Princeton Plasma Lab and asking, can we come up with entirely new designs of fusion reactors? Stellarators, which is an old idea but never really scaled up. First, can we build good digital twins of those and do a lot more testing computationally and come up with ways of uncertainty so we can get an idea before investing a lot in building in the physical world? And that's where I see the whole paradigm of ideation, testing, and feedback all driven with AI now, and making that process much faster, sometimes 1 million times faster than what we could do before.
Dr. Krishnan, I know you mentioned not having to go to the AAA to get a map anymore. That's all well and done, but you and Dr. Mitchell have spent a lot of time on the future of work. I'm curious about the ubiquitous changes in the workplace that you see.
Yeah, I think the really interesting way of thinking about this, to my mind, has been in thinking about what the technology is going to enable. But first, we need to think about, what are occupations? How might we think about occupations? So the Bureau of Labor Statistics publishes a taxonomy of all the occupations in the United States. There are 873 of them. And each of those occupations are broken down by tasks that need to be done by an occupation. If I was a plumber, if I was a business analyst, what tasks do I have to do? What skills do I need to perform that task? What is the importance level of that skill? And what is the level of proficiency of that skill that I need to actually perform that task? This is sort of the abstraction of work that is offered by the Bureau of Labor Statistics. Now, one of the things that's really interesting to think about, building on what Anima was saying, is as technology evolves, as AI technology evolves, one could ask the question, what kinds of skills does the technology have and what kinds of tasks can it perform? That's technical feasibility. But technical feasibility has to meet economic viability. And that's based on how frequently a task is done. If a task is done very infrequently, you can't amortize that cost over a large number of repetitions of that task. Versus if it's something that is repeated very often, you can amortize the cost more often. So I think where technical feasibility meets economic viability, and you have to combine that with social norms. Those three things, technical feasibility, economic viability, and social norms, are going to decide if AI is either going to augment or substitute the performance of a task by a human. And that in turn will mean that the skills required to perform an occupation are going to change. And when that happens, if you have individuals who are performing a given occupation, if skills are going to change of particular tasks, not of the entire occupation, but for particular tasks in that occupation, how are we going to potentially get these individuals trained and move, maybe upskill them or reskill them in ways that would allow for them to migrate potentially from occupations that are declining in demand to occupations that are growing in demand. And these transitions from one occupation to another, again, AI can be very useful in being very data-driven about where those opportunities exist. And if these transitions are going to be transitions that are high-quality transitions, I mean, you want people to transition from an occupation to another occupation that potentially has better wages, better quality of life, etc. So I think there is a real opportunity to think about work and how it's going to be transformed. So this is AI applied to social systems, but to do so in a data-driven way, in ways that could actually be very beneficial to workers, to individuals, to firms, and to society as a whole. So it's super exciting to think about the opportunity to prepare our society to potentially changes to come, and how we might provide advance warning of where significant changes might happen. Like, for instance, we don't have toll collectors anymore on our highways. That job is gone because that task that the person performed has been completely substituted by technology. But if you look at the teller in a bank, there are more tellers today than when the automated teller machine was introduced for debits and credits. The teller is doing different things today than what the teller used to do, but it's evolved and changed. So are we going to see the toll collector kind of situation happen every time? I don't think so. Is it going to be more of the the teller machine kind of situation? I think you're going to see evolution and change, and perhaps new roles being created, new tasks being created. And certainly there's going to be sunsetting of some occupations, in which case we have to do the transitioning that I spoke about. So I think it's really an exciting opportunity for us to think about how we might help society.
Just want to come to the end of the table real fast. Dr. Rus, you said you had a specific example as he was talking.
Oh, I was very excited to hear you talk about the fact that just because it can be done technically doesn't mean it makes sense economically. Because my colleague Neil Thompson recently wrote a paper where he studied exactly this statement, and he studied it with respect to inspection tasks, which are tasks that Tom studied in many of his papers. And it was very interesting. I guess the case he considered was bakery. So you have a bakery, you have one person who inspects whether the dough looks okay, but that person does a lot of other things. Well, we could put a computer vision system to solve that problem. It's absolutely doable. But then it costs a lot to buy the computers, to hire the AI experts, to collect the data, to go through the computation. And so this is a short task that is done by someone who does multi-purpose activities in the bakery. And so it doesn't really make economic sense to do it. However, if it was possible to build a solution that can be used by all bakeries, then all of a sudden the cost gets amortized, just like you said.
Yeah. Dr. Mitchell, what type of economic transformation are we looking at with some of these changes? And I know you had specific feedback about the rulemakers and the way they're looking at it. How should they be looking at these types of changes that are going on in the workplace due to AI?
Well, I guess one point I want to make, by the way, I want to put a little plug in. The National Academy of Sciences is doing a study on AI in the future of work. It turns out I'm co-chair of the study, but the report will be out in about a month. So I urge you all to take a look at the report when it comes out. And I just want to pick up on one theme that was mentioned here of certainly AI will impact the workforce in various ways. And so inevitably, this will put higher value on education, continuing education, training, and beginning education too, K through 12. And the point I want to make is that AI can be part of a solution for improving education. And I'll give you an example based on some work that we're doing at Carnegie Mellon jointly with a nonprofit called CK12.org, which offers online education, kindergarten through 12th grade students, and has already had over 200 million students, distinct students, visit their site during the 15 years that they've been in operation. As a result, that system, that online education system, has more experience teaching than a human could get in a 100-year career of teaching, by far. And the opportunity that raises is the opportunity to learn to use machine learning to learn to teach better based on the experience of having taught hundreds of millions of kids. And so to give a concrete example, we've been able, in collaboration with CK12, to use machine learning to discover which of half a dozen hints is going to be most effective for which student. If they miss a question, they get a question wrong, which hint should we give them before they try a second time? And because we have such volume of data, it's possible to actually come up with very statistically significant results that show which hint works best. This is just the tip of the iceberg, because now that we have systems like GPT and large language models, it offers a whole new layer, a whole new generation of kinds of things AI can do to help. For example, make up its own hints, replace the hint by a short conversation. Why did you get that? Why didn't you choose this answer? And then have a short conversation with the student. Or even begin with a discussion of what the learning goals are with the student and make much more personalized interactive education. So as part of this big picture of thinking about future of work and the impact and the needs for continuing education and training, it's very interesting to see that there's an opportunity yet to be fully proven or developed, but a very interesting opportunity for AI to play a role in that kind of training and education.
Dr. Anandkumar, ChatGPT has sort of entered the proverbial chat. I know you've been working a lot with language learning models, even in Minecraft. I'm curious what you think the potentiality of that technology is, how far it can go.
Yeah, I mean, there's a lot of exciting use cases with language models, right? So, this is work we started doing at NVIDIA, even from the very early work on language models. So I don't know how many are aware that the open source frameworks that we provided to the community to be able to train large language models is what OpenAI used, and this is where we are today based on that. But then the question is not just have humans prompt the model once to get an answer, but really think of this repeated interaction. And how can you gather knowledge from these repeated interactions to convert from language to action, right? So to actually solve tasks either in the physical world or in the virtual world. And so early on, just right after ChatGPT was released, we had been working on Minecraft, and we wanted to ask, how can language models help solve difficult tasks in Minecraft? And we chose Minecraft. I don't know how many of you have played with Minecraft or maybe have kids that play with Minecraft. Yeah, a few. And the reason we chose Minecraft was it's what we call an open-ended learning environment, meaning there is not just one goal to finish, right? It's not like you go win a race and that's the end of the game. But you can repeatedly build interesting structures like castles, slay dragons, mine diamonds. So it's a very creative, open-ended game. And by using language models, we could create AI agents. So this was some of the first work showing as agents that can repeatedly interact with language models. They gather knowledge, but then they convert it into action. So they look at solving a variety of different tasks. And you can also build up a curriculum. You can ask language models to suggest what is an easy task first for the agent to solve. And so it builds up that skill, and it remembers all the tasks that were solved. And a lot of the tasks, both in the virtual world as well as many real-world problems, are compositional, meaning you build on those simple skills to solve a more complex task. And that's how we could show this learning that never stopped. So, we are very much inspired by Tom Mitchell's work on never-ending learning system on NEL. And this is, I think, with language models, we can really enable that. And that, to me, is the future of repeated interactive learning as AI agents using language models and going and solving tasks. In fact, just this week, I have students presenting using this paradigm to also learn reward function for robotics, like how you can have now robots solve a variety of different tasks using language instructions and also come up with good reward functions to help it do reinforcement learning and solve tasks like a four-legged robot, like in fact balance on a yoga ball. So that's something they used language models to help design the reward functions to do it. So I think a lot of cool robotic tasks which require interaction, as well as in the virtual and in software development, which is repeated interactions, we'll see this kind of agentic learning.
ChatGPT has generated a whole conversation about AI and risk. Dr. Krishnan, I know you've talked a little bit about in the past and in your work, the desire to analyze whole system analysis when it comes to AI-enabled risk. I'm curious, some of the examples that you see in terms of the whole system and how it's being affected by the advancement of AI.
Yeah. So I think this is a really important distinction to make between the AI model versus the AI system. In particular, I work a lot in AI for societal decision making or enterprise business decision making. And in these contexts, you certainly want to think about starting with understanding all the steps in the AI system's life cycle, from problem formulation to as determining data and the data provenance, all the way down to the model creation, the testing, evaluation, validation, verification, on to deployment, and then monitoring and testing, and then closing of the loop. So there is the system as in understanding that whole life cycle. But then if you think of almost any practical kind of application, be it at the level of, say, in loan granting, or where the AI might make a recommendation, the model makes a recommendation. It's a model that's been tuned to particular settings, particular application contexts, and then it makes a recommendation which may or may not be accepted by the human who's in this loop. And the system, the model plus the human, or model in the workflow that actually results in the decision, it's the decision of the system that actually creates either the harm or the benefit. So not just of the model, but of the entire system. So it's important to, certainly you need to evaluate the model and understand its performance, understand how well it can be calibrated for benchmark cases, test cases, etc. But it's really important to understand the system as a whole, because a model in and of itself is not really going to be the one that actually causes potentially the outcomes that either create the benefit or the harm. So that's the perspective that I've been writing about and conveying.
Doctor, how do you think about the risk, harm, benefit calculus, especially when it comes to the intersection of AI and robotics?
Yeah, I mean, that's a very important question for robots, because robots are safety critical systems. Today's AI makes inexplicable mistakes. We can't have that on our self-driving cars, or our any other applications where robots operate in the physical world. And yet we do want AI brains for our robots. And so it's very important to think about what are the characteristics of physical devices like robots, but not just robots, other physical systems like sensors or the power grid. These are all physical installations, and the physical installations are usually small. They cannot have enough space for server farms. Today's AI often requires server farms. And so an interesting question is, how can we get variations or new models for AI that can be run on the body of these edge devices, as they're called, on robots and other edge devices, and that are also guaranteed to not make mistakes, that are explainable, and so forth. And so for robots, we have two approaches to addressing the risk and error problem. One approach connects machine learning with control theory, and we call that barrier function. Essentially, we can take a machine learning model, we can add a layer to it, and this layer essentially forces the output of the system into a safe region. We still don't know how that decision was made, but we know it's safe. because it's forced to be safe. So for instance, for a car, you can force the output to be within the driving limit or within the scope of the steering of a car. And so that actually brings some safety. But we also want to get at the decision making of these systems, because especially if they're safety critical, it's important to understand how they make decisions. And our machine learning approach, called liquid networks, actually results in much smaller, much more compact models that can then be mapped onto decision trees that will tell you exactly what the role of every neuron is in the decision making. So the point is that the research community is thinking deeply about these problems and moving forward with some solutions that are technical. But not all problems not all challenges will be solvable with technical solutions. So we also have a lot of conversations at the intersection of technology and business and policy. And Tom has been leading some very important conversations in this respect.
Yeah, Tom, we're getting close to time, but curious about your last word on the risk and the conversations that you're leading at the policy space.
Well, I think in considering the risk of AI, we have to consider the risk of humans. So my take is we have been tricked into thinking that computers can be infallible because they can multiply matrices perfectly and they can add numbers perfectly, and they can, and they are infallible in those tasks. But AI is moving us into a new regime where we're asking it to do tasks where infallibility is it's just unrealistic. How can you be infallible in picking the direction the stock market is going to move tomorrow? You can't. You can be better than chance. You can be better than any person, but you're not going to be infallible. It's just the wrong thing to aspire to. And so when we think about what are the constraints we need to put on AI in order to allow them to collaborate with us humans, we should be realistic about how infallible we humans are in that same process. And my colleague Rayad Ghani put it best in a simple sentence. He raised his hand in one of these discussions and he said, why are we not using the same vetting that we use on humans, the same evaluation and testing we put on humans before we allow them to practice some medical procedure or something? Why aren't we using that same procedure to test computers? Why are we requiring perfection? So I just want to leave you with that thought, that I think perfection is it's just a crazy idea as a general purpose idea. It works for arithmetic, but not for the soft skills.
Can I just make a quick comment about?
We're at time, but very fast.
Yeah, very quick. So the NIST with its AI risk management framework has actually captured a lot of what Tom just said, because the process by which we come up with these thresholds that are acceptable is a social process as to what's acceptable, what's not. It's not technically possible for us to define it. So the framing that Tom offers is spot on.
My mistake. I think we're actually have a couple more minutes. I know people have to catch flights, but quick lightning round. I'm curious about, all of you are both in the university environment. Curious what you're looking at as sort of the major role of the university in helping out the innovation process. Dr. Anandkumar.
Yeah, I mean, absolutely critical, and especially in the areas of science and engineering, and thinking about what big tech isn't like putting a lot of energy, right? So how do we put AI into these broad areas and also create open data sets, open source frameworks to enable innovation? I think that role is critical.
Dr. Krishnan.
The quick thing is, throughout our history, universities have played a really important role in being an actual important part of the innovation process. And it has to do with being multidisciplinary, being able to convene and taking the long view, not necessarily just a short-term view on innovation. So a really important role to play.
Quick response. I think that when we look backward from 2027, we're going to see that advances really did occur from the very large investments made by large companies to build $100 billion LLMs. But I think we're going to see greater advances came from universities that were looking at more diverse kinds of approaches, including moving away from building AI as a single individual intelligence like ChatGPT and moving toward societies of cooperating, interacting agents.
All right, two very quick comments. Universities are hotbeds of innovation. Universities are focused on advancing knowledge. Companies are focused on profits. So universities are incentivized to push the boundaries on what's possible.
All right. Pushing the boundaries is a great way to stop. Thank you so much to our expert panel. Thank you to our audience for enjoying, and enjoy the rest of your expo. Thank you so much.
Thank you.
Yeah.
Thank you.
And thank you.
You know.
Thank you.